Hello, welcome to this video. In this video, we are going to look at um, lenses and the images that are formed by them. This is Tutor PVS and this is Genius Pro Online School. Figure 8.1 shows a ray diagram for a thin converging lens. Converging lens is a type of a lens where the lines they are able to meet somewhere and form the image there. The lens forms an image of the object. The object is positioned 30 centimeters from the center of the lens. I think you can see that distance from there to there. Okay. Next is we can also see that from the center to there it's 8, and again from there to there it's what 3, and the image is being formed there. Question 1. Determine the distance of the image from the center of the lens. Use the information from the figure 8.1. So we are looking for the what? The distance of the image. The image is here. So we are looking for the distance of the image from the where it is all the way to the center there. So that means we are adding this distance there and that distance there. So 3 plus 8. So from there to there. So what is 3 plus 8? 11. Now they are wanted in meters, and these are centimeters. So careful. So that would be 11 centimeters. We convert to meters, we divide by 100 to give us 0.11 meters. So we write 0.11. Determine the focal length of the lens. Use information from 8.1. Now, the focal length is usually the distance, all right, from the center of this lens all the way to the focal point, all right. Now, in our case, our focal point can only be determined by this line. This line here is helping us find the focal point. So the focal point, where this line cuts the principal axis, this line here, this line that we are seeing here is what we call the principal axis. Where this line coming down, it cuts. That's where we have our focal point. And the distance now from there to there is what we call the focal length. So that is a focal length. And what distance it is? 8 centimeters. But they want it in meters. So we divide 8 centimeters by 100 to give us 0.08 meters. Moving together, right? Next. State 2 characteristics of the image formed by the lens. Now look at the image. What are some of the characteristics that can be taken from this image? Number 1, the object is upright, but the image is facing downwards. You see how it is, right? Again, look at the size of the object. It's larger than the size of the image. Again, we can say that the image is smaller or it is diminished. The other one is that because one is down, the other one is up, we can say the image is actually inverted, or we can say it's upside down. Now, an image formed on the converging lens is always real as long as they are laterally inverted. They are always real. All right. So we can put, for example, it is diminished. It's diminished, meaning it is smaller. Also, we can say that it's upside down, so we can say it is inverted. Or we can say upside down. I'm going to add the third one. It is real. Because it's upside down, it's real. B. Okay, I think that's the only part I wanted to show you. That's the only part I wanted to show you. But let's go to part B as well. Figure 8.2 shows labels for part of the electromagnetic spectrum in order of decreasing wavelength. So now we are decreasing wavelength. So wavelength is decreasing. So we have visible, ultra, and so forth. So of course, if the wavelength is decreasing, that means the last one should be gamma. Should be gamma. And the first one is always what? Radio. If the frequency, if the wavelength is decreasing. because as you decrease the wavelength, what happens? Frequency increases. Okay, so now complete the figure 8.2 by writing the name of one type of radiation in each box. They want us to know there and to know there. All right, so actually, the electromagnetic radiation that comes after ultraviolet is actually X-ray. You can even write X-rays, it's fine. The one that comes after X-ray is gamma. Gamma ray. Okay. Number 2, state one use of ultraviolet. One use of ultraviolet. Now, it has a lot of functions. All right. Number 1, it is used as a security marker. Number 2, it's also used in in money, in banknotes. It can be used to detect if the money is fake or not. They use ultraviolet radiation. It can also be used in sterilization of medical equipment, water as well as food. So, which one are you going for? Any, right? It can be used in as a security marker, or it can be used in detecting fake banknotes, I think let me just give you those two. State one danger to people from excessive exposure to ultraviolet. If you are exposed to ultraviolet, what danger are you putting yourself in? Well, there's only one. It's either they damage your skin, or they damage the cells, or the eyes. So there's damage. They damage. Now, what do they damage? They damage the skin. They also damage the eyes. Or cells. We're done. Done. Perfect. All right. I'll see you in another video. Please subscribe and follow for more. In law for revisions, please. Straightforward. I think you've seen how I'm explaining. Imagine now if you're my student.